Alright, so in this question we're looking at a number of different sequences, and we're being asked in each sequence to calculate the first 5 terms of the sequence, so the number that each term represents. And the first sequence that we're given is made up of matchsticks, and we are asked to count the number of matchsticks in each term. So in the first term we have this square made up of matchsticks, and how many matchsticks is that? Well, it's 4. 1, 2, 3, 4. In the second one we have the original square from the first term, but then we have another square is added on. And how do we do that? Well, we add 3 more. So now we have 7. In the third term, we have, I'm just going to copy the second term over. And then we are once again going to add 3 more to end up with 3 squares. So how many matchsticks do we have now? Well, we had 7 in the second term. We added 3. So now we have 10. In the fourth term, we have the same thing as in the third term, but we are once again adding 3. So 10 plus 3 will be 13. And for the last one, we're going to repeat the same action to end up with 5 squares. 13 plus 3 is 16. Now the question says, try to explain how to calculate the 10th term. So let's think about it. We started off with 4, and for each subsequent term we added 3 more. So for the second term we added 3 once. For the third term we added 3 twice to the original square. For the fourth term, we added 3 times to the original square. So for the 10th term, what if we add 3 9 times? Oops. 9 times to the original square. So here's the original square. 3 once, 3 twice, 3 3 times, 3 4 times, 3 5 times, oops, 3 6 times, 3 7 times, 3 8 times, 3 9 times. How many squares do we end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had 4 to start off with, and then we added 3 9 times. What does that come to? 4 plus 27, and we probably have 31 matchsticks in that sequence. So that's one way to explain it, but you may have your own. Let's look at part B. In part B, we're counting a sequence of dots, and as you can see, the dots kind of look like frames. So in the first term, we have 1, 2, 3, 4 dots, so our term will be 4. In the second term, we have 1, 2, 3, 4, 5, 6, 7, 8 dots. So it's almost like a 3 by 3 collection of dots, but there's one missing in the middle, so we have 8. What about 3? For the first position, for the first term, each side of this little square had 2 dots. For the second term, it was 3 dots on each side. For the third term, there are 4. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I'm kind of seeing here, what this looks like to me, is kind of like if we had a 4 by 4 square and then we took out a little 2 by 2 square. Just something to keep in mind. Let's look at the fourth term. So how many dots on each side are we going to have this time? Following the pattern, it will be 5. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 3, 4, 5. Okay, so we can count how many dots we have. 5 on one side, 5 on the other, and 4 or 3 in the middle on each side. So that's 5 plus 5 is 10. 3 plus 3 is 6. So we have 16 dots. And let's look at it once again in the same way that we looked at the third term, where we kind of imagined a square with the middle taken out. So what does the middle look like? Well, it looks like a 3 by 3 square. Okay, so we had a 5 by 5 square and we took out a 3 by 3 square. It's kind of like if we said 5 squared minus 3 squared, which we know is equal to 25, minus 9, which is 16. Aha, and that was our term. What about the third term? We had 4 by 4 square, 4 squared, minus a 2 by 2 squared, 2 squared, which is equal to 16 minus 4, and that comes to 12. So we're on to something. It seems like every time we have a term, we have a square with another square that is missing from it. So let's investigate this a little bit further. Let's try to find term 5 and then see what we can summarize. Okay, so for term 5, we know that we're going to have sides that of 6 dots, because that's what our pattern's been doing. 6 by 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, and we can count that. So 6 plus 6 is 12, and plus 4 is 8. So 20 dots in this term. And let's look at it the same way as we did before. So what's missing in the middle is a square that is 1, 2, 3, 4 dots by 4 dots, all filled in. Okay, so interesting. Let's write that down. So here we had a 6 by 6 square, and we took out a 4 by 4 square. What is that? 36 minus 16, and indeed that is 20. So it seems like for every position, for example, position 4, we have a larger square that is made up of sides that have the amount of dots is 1 greater than that position. So for example, for position 4, we had sides made up of 5 dots. And then we have a smaller square in the middle that comes out that is made up of an amount of dots that's 1 smaller than that position. So every time, so for example, so for the 5th term, for example, we said 5 plus 1 squared, that was 6 squared. And we took out a square that was made up of 5 minus 1 squared. So that's how we got 6 squared minus 4 squared, which ended up being 20. So now, how would we find out what the 10th term was going to be using this pattern without drawing it? Well, let's try to use the same idea. For the 10th term, we need a square that is made up of one more dots than the number of that term. So the larger square is going to be 10 plus 1 dots on each side. And then we're going to take out a smaller square that is made up of 10 minus 1 dots on each side. So what does that come to? What is 10 plus 1 is 11. 11 squared is 121. And what is 10 minus 1 squared? Well, 9 squared is 81. 121 minus 81 is 40. So once again, you might have found a different way to come to that conclusion. You might have found a different pattern that leads you there, and that works too. Let's look at part C. Okay, for part C, we're given dots in a sort of triangular form. And let's observe what we have here. So in the first term, we have 1 dot. So here's, in the second term, here's that 1 dot again, but this time we've added 2 more. And then in the third term, we have the same triangle from the second term, but we've added 3 more. And so on. In the fourth term, we add 4 dots to the previous term. Okay, so how many dots do we have? In the first term, we had 1 dot. In the second term, we added 2 dots to the first term. That leaves us with 3 dots. In the third term, we added 3 dots to the third term, which gives us 6 dots. For the fourth term, we added 4 dots to the third term, which gives us 10 dots. And in the fifth term, we added 5 dots to the fourth term, which gives us 15. So see that this one always carries over. Just like that. Okay, so if we were going to find the 10th term, can we just guess what it is based on knowing that it's the 10th term? Well, unfortunately, in order to know the 10th term, we're going to have to know what the 9th term is so that we can add 10 to it. But in order to know the 9th term, we need to know the 8th term and so on. So we're going to have to add them together from the beginning. Let's do that. So the 10th term will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 Okay. And if you do the math, that comes to 55.